Hi everyone, this is Ayatya and I'm here with my team members Giri and Krishore. We are group 19. Today we are going to discuss the second group presentation, second reading for the group presentations. Autonomous agents and multi-agent system, that will be our first topic we're going to discuss today. So autonomous agents are intelligent agents that operate without any interference of ownership entity. It's provide a new way of analyzing, designing, and implementing complex software systems. Recently, we can see the agents are used in wide range of applications, such as personalized email filters or the air traffic control systems. When we talk about the autonomous agents, we have to understand what agents is. Agent is the computer system that is capable of performing flexible autonomous action in order to meet some goals. Key concepts of agents are situatedness, autonomy, and flexibility. So when we say that, we have to, let's go in deep a little bit and understand what that means. Situatedness of agents is that when agent get a sensory input from its environment and it's used that information to perform action. So that means it will monitor the environment situation and take action based on that. Autonomy means when performing a task without any, it can perform a task without interaction of any human or any other agent. And when it comes to flexibility, that means system has to be responsive, proactive, and social. So there are like some example we meet in our day-to-day life, like with autonomous agents. Examples are like thermostat that we use, and also nuclear reactor system, reactor control system. Autonomous agents is designed to perform its task without interaction of humans, as we discussed earlier. But it has like main three contributors: artificial intelligence, object-oriented programming, and concurrent object-based systems, or human-computer interface design. Intelligent artifacts sense the environment and then take the appropriate action based on that information they received. Intelligent behavior, when we talk about the intelligent behavior, it has like a couple of components like learning, reasoning, problem solving, and vision understanding. Reactive agents also can respond to changes in their environment. When it comes to AI planning, AI is mostly concerned of how build the intelligent artifacts that can sense the environment and make action accordingly. AI planning is not like a really new thing. It has been introduced like long time back with Neville and Simon's GPS system. That was the first time we have seen that AI planning was introduced. And also there's concept called first principle. It is one of the techniques that formulate new plans for the program to define a goal, to like fulfill the task. In early 1980s focused on planning algorithm by themselves and identify the list of actions that need to be taken. The examples are strip style system. So strip style planning algorithm is one best example. And it also has multiple components such as symbolic model of agent environment and a symbolic specification of actions. Object and concurrent objects. When it's come to objects and concurrent systems, objects are like, first we talk about objects. Objects are like computational entities that that has some state associated with it when they perform their actions. Object-oriented programming, also something we introduced recently, and it has like it has a mechanism that we could implement the object, and object can control its own states, and then it can be used to make their decisions. For example, Java, C#, C++ are object-oriented programming languages. Object has control over its state, but it doesn't exhibit control over the behavior, its behavior. Since we are talking about objects and agents, let's quickly go through some differences between objects and agents. Agents can be implemented using object-oriented techniques, but autonomy is not a component of basic object-oriented mode. And also agents have control over their own behavior, but object is totally depending on one another, which means that they don't have the autonomy over their behaviors. So object-oriented approach defines static inheritance, whereas that agents has complex relationship between each other. When it's come to human-computer interfaces, humans usually interact with computers via different types of interfaces. So, for example, we can use a keyboard or a monitor or like a voice input, something like that, to give our instructions to computer system. When we are talking about human-computer interfaces, we usually talk about paradiagrams that is known as direct manipulation. The system, in simple words, computer usually can do things if we teach it to do, how to do, or like what to do and when it has to happen. With the time, people were trying to invent a system that could respond to users without wanting human to teach them before. For example, expert assistants or a digital bottles. Multi-agent systems, also known as distributed artificial intelligence, and that can be distributed artificial intelligence. It can be divided into two sections, which is distributed problem solving and multi-agent system. Distributed problem solving means the problem will be divided into multiple modules, and then all modules will be communicated and cooperated each other. When they are doing that, they will be sharing the memory and also knowledge of the problem. When it's come to multi-agent systems, use the collections of pre-existing autonomous agents to solve that problem. So there are some key characteristics of multi-agent system, such as each agent has incomplete information. That means it has to be communicate each other in order to produce the final output. And there's no global control, and data will be decentralized, and it will do the synchronous computation. Cooperative multi-agent interaction means cooperative multi-agents are working together to reach one internal goal. In order to improve the performance of cooperative multi-agent system, agents interaction must be guided. So there are a few other applications introduced for that. Sharing problem between nodes and knowing which node does what is helpful in order to come up with a final solution. There are other approaches as well. So for example, functionality accurate model is one other example. When it's come to self-interested multi-agent interaction, self-interested multi-agents only care about things that are beneficial for them. And then that the agent has its own description of description of the problem. When it's come to interested agents, negotiation became a key factor. So negotiation can be used as representation of communication, or like planning changes or task association, or finalizing the solution. Um, the procedure system represent the first work by DAI research on negotiation between self-interested system and agents. So let's move to the second section, and my friend Giri will continue from here onwards. Thank you.
Thank you, Ayodhya. Now I'm going to discuss about the issues and the applications. Coming to the issues, one of the most important factors in the software development is the internet. Agents must communicate in order to reach their designers' objectives. Early experiments revealed that middle agents have certain characteristics. These agents are more flexible and can tolerate a fast changing workforce. There are a number of languages that allows agents to communicate without being bound by the rules or regulations. Another key issue is the efficient distribution of limited resources among several agents. One of the issue is that agents may misuse shared resources, and agents may mislead one another in order to increase their utility. And coming to the applications, the agent-based applications are used in the industrial applications, commercial applications, entertainment applications, and medical applications. In the manufacturing applications, YIM means yet another production systems uses the contract net protocol to control manufacturing. Work cells are arranged in the logical manner to represent a manufacturing company. These work cells are divided into flexible manufacturing systems to perform specific tasks. A group of flexible manufacturing systems is called a factory. A single organization may have multiple factories with some of these duplicate operations and features. The YIM's use is to manage the manufacturing process as efficiently as possible. In the process, the parameters will always change. So to complete the task, YIMs use a multi-agent approach in which each factory and factory components is represented as an agent. The another application is the process control. Process control is the perfect application for agents and is known as the self-reactive systems. Arcan is one of the known agent-based process control application. Arcan is one of the world's first field-tested multi-agent system and is also used in a lot of process control applications, including electricity transportation management. Another agent-based process control systems were developed for monitoring and detecting defects in the nuclear power plants, spacecraft control, climate control, and the steel coil production control. There are two types of agents in the transportation system. One agent checks with customer needs which customer needs a transportation, and another agent checks the customer location. Customer service representatives notify relevant stations of their needs, and the station agent evaluates whether the demands can be met, and if so, uh, if so, which car they should be booked into. And coming to the commercial applications, in our daily lives, we, uh, we have access to a greater variety of different forms of information. So the necessity for the information management has increased. The information overload problems has increased due to the absence of efficient information management services. There are two types of information overload issues: information filtering and the information gathering. Information filtering means we will get a large amount of information every day. For example, from email, from news. Among them, only some amount of information is useful for us. So we must be able to separate and concentrate on the information we require. The information gathering is we are unable to find the information to answer requests due to the high volume of information accessible. We must be able to obtain knowledge that suits our needs, even if the information can only be obtained from the variety of different sources. And coming to the electronic commerce application, almost all parts of the business is controlled by the human interactions. Humans choose when to buy and how much they are willing to spend. Some of the known commerce applications are Kasba, a bargain finder, Django. This Kasba creates a marketplace by generating the buying and selling agents for each product to be purchased or sold. The bargain finder application shows the cheapest products, and the Django application is a personal shopping assistant which checks that the product is available in the online stores or not. And in the business process management application, gathering the information from the large company is very hard and the time consuming process. To solve this problem, adapt is designed. In this, each agent is assigned with a particular task in the company and provide the one or more services. If the agent needs a service from another agent, then the agent participate in the service discussion with the other agent, and they are mutually beneficial in terms of price, time, and the quality. And in the entertainment applications, agents play an important role in computer games, interactive theater, and the related virtual reality applications. Grand and Cliff created the creature games by using the agent methods. It contains different agents where the users can play in the real world. In game, the agents are designed as the clever pets whose development is influenced by their experiences. Computer characteristics have the real life behavior while dealing with the artificial. In the interactive theater and the cinema, agents are the software programs that gives the appearance of the life. It plays the role of humans in the theater style applications. In the patient monitoring applications, the Guardian system is developed for the patient monitoring. The system was created to address two issues. One is to form a team with a group of professionals from multiple fields works together to organize the patient healthcare. And the second one is the appropriate information sharing among the team members. The Guardian system distributes the information with the three types of agent. They are action agent, reasoning agent, and the control agent. The action agent is responsible for creating a connection between the guardian and the outside world, and the reasoning agents are responsible for handling the decision making process in the system, and the control agents is everything in the system and it top level control of the system. And in the healthcare application, the patient management process, which mostly involves several people, is designed to be integrated by an agent-based distributed medical care system. For example, a doctor believes that the patient has a disease, but without the help of the hospital specialist, the doctor opinion cannot be confirmed. If the specialist confirms the disease, then the treatment plan for the patient must be created, including resources of other people. Here, the agents are the people who involved in the patient care process. Now my friend Nanda will continue. Thank you.
Yeah, hi. And now, hi Giri and Ayodhya. And now the multi-agent learning for engineers. In this topic, we can be able to know about the multi-agents for engineers to learn. And the paper was written by Shay Minur, Jeff S. Shema. Here it is given the answer, and we need to find the question for this. If multi-agent learning is the answer, we can find the question by looking at the engineer's agenda. It explains about the macro or macroeconomic phenomena using the simple learning rules and the predictive agenda. It says that by this we can be able to know what will happen. In section 2, we says that about the use of the multi-agent learning in these domains to make simple the process of an distributed control system by some of the following methods, like reducing the complexity, account for uncertainty, allowing for distributed interactions between the controller. And coming to the section 3, we discuss about the issues in the engineering view of multi-agent learning, descriptive and predictive views. And in the section 4, it says the conclusion on the engineering agenda with an outlook and the challenges it poses to the multi-agent learning. And next, coming to the why is multi-agent learning. The problem of the designing optimal or distributed control system is very difficult. In general, it is not easy to pass all the information uh, to a command center that could process this information and eliminate the instructions. Even if it is possible, the complexity of it is high. Um, so that construction of a centralized optimal policy is intractable. And Nash equilibrium, it plays the major role in multi-agent learning. Nash equilibrium, the what is about the Nash equilibrium means it is the most common way to define a non-cooperative game solution. In Nash equilibrium, each player is assumed to be aware of the other player's equilibrium strategies, and no player stands to gain by merely altering their own strategy, because everyone has their own strategy to gain something in that game. So that the Nash equilibrium plays a major role in this, and multi-agent learning is an effective approach to the problem that is said earlier days. Basic elements of players, strategy spaces, player utilities, consider all designs when imposing a multi-agent framework. We must define a specific game to apply by this learning. And coming to the Nash equilibrium, different justifications are required for the significance of the Nash equilibrium. In engineered systems, the Nash equilibrium concept is so general that a desirable solution can be expressed as a Nash equilibrium, but only for some appropriately defined games, not the many games. Only for some defined games only the Nash equilibrium is mainly used. The ideal game is not used in the in the multi-agent learning setup for a variety of reasons. And however, there are times when average performance criteria are insufficient. In military operations, this is a clear example. In the absence of extremely large teams, especially in the worst case or at the least risk average case, performance measures are preferable. The presence of emergency 911 and other critical network traffic is a similar concern for network routing, and for this Nash equilibrium is used. And it is certainly possible to use offline simulated multi-agent learning as virtual experiments to fine-tune a decision-making policy. Even with this application, there is a still of a need for multi-agent learning framework that provides guarantees on performance that is better than the average ones. And coming to the limited information and costly communication, Nash equilibrium is one of the main things in multi-agent learning. It is characterized by using the limited behaviors of various algorithms. The ideal game is not very much easy, and it is mainly used in the multi-agent learning. And coming to that performance, when it is working, how to perform a task and extremely at large teams, that is in the worst or the least case, it is used. And the information, the limited information, the information that is limited, it means only for the agent in a engineered system as a design consideration and influenced by specific domain. And the information must be kept as secret as you can, and determined by modeled settling. And the utility communication cannot be assumed in the social modeling context. It reflects an agent's underlying intent. And coming to the concluding the remarks, the engineering agenda. The engineering agenda in multi-agent systems differs that the economic game theory agenda. In this, we have the two additional factors. They are important for engineering systems. They are robustness and domain knowledge. Mainly, these two factors are used in the engineering agenda. And robustness is the quality of being physically and mentally strong and healthy. When applied to a system, it refers to the ability to tolerate perturbations that may affect the functional body of the system. In the same vein, robustness is defined as a system's ability to resist change without changing its initial stable configuration. And the robustness in the small refers to the situations which perturbations are small in magnitude, and with the small magnitude hypothesis being difficult to validate because small or large depends on the specific problem. Robustness in the large problem, on the other hand, refers to the situations in which no assumptions can be made about the magnitude of perturbations, which can be small or large. It has been discussed that robustness is important. And coming to the domain knowledge, domain knowledge as opposed to general knowledge is the knowledge of a specific specialized discipline or field. The term is frequently used to describe a more general discipline, such as a software engineer who has a general knowledge of computer programming as well as a domain knowledge about developing programs for a specific industry. The domain knowledge holders are frequently regarded as specialists or experts in this field. Thank you.